Um,
We're live. Look pretty.
hmm?
I said we're live. Look pretty.
So how did we do on the lesson?
I think
I
it
didn't
was.
think that was too bad.
Yeah.
I got a
Do
little
you have any questions?
sorry, I got a little confused where they were pulling the numbers out of places sometimes.
Oh yeah. Yeah, I had to keep practicing that over and over.
Does anybody have any other questions? Any questions in the preparation?
I'm okay. I don't feel like I'm brilliant at it, but I feel like I'm okay.
Yeah, I'm never going to get it.
You're just ready to dive in. See if you can
Alright.
swim, right?
Let's do this.
Okay.
Yeah.
15 questions.
How many?
15.
That's not too bad.
Well, it's only actually 13. You don't count 13.
Touche.
All right.
So we're ready to get started?
Yeah.
As good as it's gonna get.
Kirsten, you on board?
Yep.
Okay. So number 3, in previous lessons we have assumed the population standard deviation was known. In this lesson we are making different assumptions about the standard deviation. What has changed?
It's unknown, right?
Right. So all that stuff we were doing last week, apparently we're not going to use it anymore.
Yeah.
You'll just use it on the exam.
Of
Yeah.
course.
It makes you wonder the point of the lesson, right? Or the class. If we're not gonna have these things, then why give them to us?
I'm not sure about that. Okay, so we're going to say we assume the standard deviation is unknown.
Mm-hmm.
Okay.
Okay, I can read 4. The null hypothesis is null hypothesis is 8, and the alternative hypothesis is less than or it's greater than 8. And the population standard deviation is not known. Vega collects a sample size of 9 and computes x bar 11, and sample size and s equals 6. This is information for question 4 and 5. Is that the funny new formula?
Yeah. But it.
Oh, but I guess the question is.
Yeah.
That was a dumb question.
Indeed.
Okay.
I think we're all gonna say no, right?
Yeah, we're all gonna say no.
Yep.
If somebody has something otherwise than that, then I need to read the lesson or something.
Well, I assume they're just trying to make a point. We don't know the standard deviation anymore. Okay, so this one, number 5, what is the value of t? That's the one we're going to have to use the formula. So we do have the x bar. We do have the mu, which is 8. We do have this s is 6. So we've got everything we need for that formula.
Yep. Let's see if my math will work this time. Oh, you didn't see it last time. I couldn't compute anything right. Thank goodness for Christy.
I got one now. Put it in now.
Or I didn't square things.
Yeah.
Okay. I have it whenever everybody's ready.
Almost there.
You know what the funny part about this is that I get to practice my math. I intern at the high school, and I go help with the ESL students, and they have math homework, and I was like, I haven't done this math in ages, but it's been really good practice because apparently you need this for this stuff.
Hey, I'm ready.
I have 1.5.
That's what I got.
Yep.
Okay, so 1.5 is our t-value. Ugh.
Alright. Okay, using the following values which were pulled from the data file body sample, copy and paste them into the software you are designed to use. Using the null hypothesis of alternative less than level A equals
Okay, we have that. We have body temp.
We have that one,
Yep.
so we don't have to copy and paste.
Let me look at the numbers and see if they're the same. Okay, somebody want to read off the numbers?
From the problem?
Yeah, please.
98, 99.6, 97.8, 97.6, 98.7, 98.4, 98.9, 97.1, 99.2, 97.4, 99.1, 96.9, 98.8, 99.9, 96.8, 97, 98.7, 97.6, 98.7, 98.2.
Okay, there's 3 more. I wonder if we can delete the last.
Does it say we can just use it, or do we have to copy and paste it?
Well, I was able to delete the last 3, so I don't see why it wouldn't work with what's already there. What do you guys want to do?
I don't think it matters. I just copied and pasted mine.
I don't even know how to do that because I've just been using the program as is and I haven't had to. Are you going to use Excel?
No.
You're just going to use a blank one?
Yeah.
You're just going to use a blank thing? Okay. Well, I'm gonna delete the last 3 and then just try it that way and we can compare answers.
Okay.
Oh. Okay, my SPSS isn't working.
Great.
Anybody got something yet?
I have 98.2200.
That's what I have.
I got 98.233.
Oh. No.
Man. Something's going on with my SPSS. It's not working properly. That's great timing, isn't it?
Yeah.
I noticed mine's been a lot slower to open, but eventually it gets there.
What did you get for the standard deviation?
Yes.
Did you color your hair again?
Huh?
Oh, Kirsten, did you color your hair again?
Yeah.
Oh yeah, it is darker.
Yeah, it's blue for
Yeah,
now.
I'm like, it's different.
I can't see it that good.
It's a good thing you're not going to school on campus.
Well, I kind of am. I just wear a wig around campus.
Oh, wow.
Okay. Okay, so what are we gonna do for the X bar?
So what were the different answers?
I got 98.233.
Kirsten and I got 98.2200.
That's great.
I think it's asking to round to 3, so we can't just...
Did somebody just copy and paste?
I did.
I wonder why it's coming up different.
I don't know, but I would be more likely to use the other numbers because I don't know if they did anything else or if they changed the hypothesis or the null value.
Did you copy and paste, Kirsten?
Yeah, I copy and pasted.
You guys can copy right off the quiz?
Yeah.
Huh, I didn't know that. Okay, so what did you get for the standard deviation?
0.92201.
Yep.
What did you get, Renee?
Mine says 0.7395. So they're really coming out different.
Okay. So what do we want to do? Do we want to redo this? Man, I wish I had SBS. What's going on? It won't even take, like, it won't even spit the numbers out.
Weird.
It is weird.
Well, I'm just gonna go with that. What I have.
Okay. What was your number again?
Which one?
Your X bar.
98.220.
And your standard deviation or your S?
0.922.
What did your are your T-scores different?
I haven't done that yet.
So is that one on there, or we just have to...
So that one, you have to go into analyze and then to the compare mean, right?
Okay, let me try it.
I'm sorry I'm not more helpful. I even like prepared directions and everything. Did you get the t-value or the t-score?
I got 476.407.
And what did you get, Renee?
This one says can't be right. It's like in the thousands.
Okay, so there's something going on with yours.
I guess
What
I
did you
missed
get,
it.
Kristen?
What did I get?
Yeah.
I computed it by hand,
Yeah.
and I got 1.843.
So you
I
didn't
would
like
go
it.
with this PSS though,
Let's see.
because if you have a rounding error,
Did you say don't go with SPSS?
no, I would go through SPSS.
Let me do it again through SPSS, and I'll tell you what I've got.
Do you have to change your test value for SPSS because you're trying to find the t-value?
Um,
I don't remember what the rule was for that.
I think it's only if you're doing the p-value.
Okay.
Christy, what did you get for your t-score?
476.407.
Yeah, that's what I got when I put it in too, when the test value is 0.
4764.
0.407. Can somebody give me the address for the probability app?
Wait, what?
Can somebody give me the probability app, the normal probability app address? I know I should have it.
I don't think you can use that with the t-score.
Oh, really?
Yeah.
So the
It's
p
not a normal.
shouldn't the p-value be, or is that the standard deviation? Never mind, it's the standard deviation. I take that back.
So yeah, you're right. You can't do that.
So how are we supposed to find, let me look at that. The p-value then, so that's the degrees of freedom.
Oh. So the p-value is 19.
Is that, did SPSS give you that?
The degrees
Did
of
you
freedom.
calculate it?
Is that the p-value?
Mm-hmm. No, the p-value would be, wait.
Guys, I think for the test value, you have to put in the,
The null hypothesis?
yeah, the null hypothesis.
That's what I thought! Sorry, just kidding.
What?
So you have to put, so when you're trying to run the test value test on SPSS, and you click on, so you're gonna do analyze, compare means, one sample t, and it'll bring up that box.
Mm-hmm.
Up, you're gonna press, at the bottom of it, there's gonna be a little, it'll say test value. You have to put the null hypothesis in there.
Yeah, that would make a lot more sense than the numbers we've been getting.
And then that would be, what is your null hypothesis?
98.6.
Yeah.
Okay. I was like,
And then to get the p-value, you leave it 0, right?
No, you keep it in the null hypothesis.
Oh, what is it that you put 0 to? What do you? Is it to get the interval thing?
Yeah, it's to get the confidence interval.
Yeah. Okay.
Okay, so then the t-value is negative 1.843,
Yeah,
right?
that's the t-value. Yeah.
And you can't put that into the normal probability app?
No, because this isn't a normal distribution. It's a t-distribution.
Wait. So what was our t-score?
Negative 1.843.
Negative 1.843. How do we still not know how to do our p-value? Let's see.
Let's see. The p-value is given to you.
Is it the sig two-tailed thing?
Yes. That's your p-value if you're doing a two-tailed test, but if you're doing a one-tailed test, like we are, we have to divide it by 2.
Sweet.
Okay.
Which would be
0.041.
Yes.
0.041.
Yes.
How you doing, Renee? You're kind of quiet.
Well, sorry, I was trying to catch up. I copied and pasted the numbers, but now I'm lost. What number are you guys on?
We're on 9, but we can help you get there.
Okay, so where are you getting the number? I understand having it, but where do you get the number to begin with?
Which number?
The p-value.
So the p-value, if you look at, you perform the t-score, the box that gives you all the data, it'll have one that says t, and right underneath it'll say the t-value, then it'll have the degrees of freedom, and the next one will be sig two-tailed, and so this is your p-value. And so, however, if it's a two-tailed test, so if our alternative hypothesis was equal to or not equal to, that would be two-tailed. But because it's I believe, greater than, that's a one-tailed test, so we divide that by 2.
Okay, so all I'm seeing is 0, point zeros. And then if I double click on it, it comes up 3.3349.
Did you,
When you perform your t-test, did you change the test value to the null hypothesis?
Apparently not.
So try running the test again. So you do analyze. Oh, snap. Okay. So just try doing it again.
Okay.
And then you do, so your analyze, compare
Is this
mean.
in Explore?
No. So you started analyze.
Right, but then do you go,
Compare means.
okay, because I already did that one.
You have to redo it again because you have to retest with the null the test value needs to be changed to the null hypothesis.
Which is 98.6.
Correct.
yeah.
Okay.
What's the t-score that it gives you?
So I'm getting a negative 1.843.
That's what we got.
Okay.
And so then you divide the sig two-tailed test number by 2.
Okay. Okay, so 0.0405. What I got.
Yeah,
0.0405?
yeah. So just do 0.041.
Yeah. Okay, yeah. 3 decimals. I got confused. I was like, no!
Because it's, oh, we just want 3. I'm like, why are we rounding up?
Yeah.
Okay, so let's see.
So are we ready for 10?
Just let me double check if I'm. So number 6 is 98.220. Is that what you all got?
Yeah.
Well, yeah, I just bumped the answers up with them.
And 7 is 0.922.
Yes.
8 is negative 1.843.
Yes.
And then 9, the p-value is 0.041.
Yep.
Okay. Thank you.
And number 10, the correct decision based on this evidence would be. So our p-value is low, so we reject the null.
Yep.
It's lower than, what was our, oh yeah, okay, it's lower. Okay, so we're going to reject.
Yeah.
We get to copy and paste again, ladies.
Oh gosh, what the heck? Why did we buy that software again?
I don't know.
It's supposed to be all done for us.
Use the following values which are pulled from the data file.
I'm afraid to close this out and start over.
You can close your solutions,
Yeah.
and as you, oh well, you can just go to file. I think there's a way that you can just start a new one.
Just refresh it. I'm just going to try deleting all the data.
Yeah, you can delete it and then just copy and paste the new stuff in
And
it.
then what do I do? Just close out the box and start over on that?
You can.
Yeah, you can.
Okay. Okay, so this doesn't copy very well. It wants to take everything, I think.
It's
No.
true.
I can just see trying to do this on an exam and freaking out.
You're gonna be okay. I believe in you.
Oh.
Christy, on the other hand, looks a little flustered.
It's not my thing. Okay?
I believe you. I believe you. You're doing great, though. You're doing so great. It's the least I can do. I have no SPSS, so I'm like, la da 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 da.
It's going to be the moral support.
Yeah.
Okay, so what's our first? Okay, I've copied and pasted. So what are they asking now?
What is the p-value?
What's the p-value?
So you need to run a t-test.
Yeah.
Don't forget to switch your test value to 40, though.
Okay.
Oh, gee.
So this is under compare the means.
Yeah, so analyze, compare the means, one sample t-test.
Put in 40.
Yeah, you put in 40.
I think I'm going to reset my variables too. It might bring up the old stuff. Okay.
So this one is 212, so we just put in this number, right?
Correct.
See? Catfish! I'm just a little slow.
You're not slow. You're doing great.
Okay, so we're looking for the p-value.
Yes.
Yeah, which
Is this two-tailed or one-tailed?
Two-tailed.
two-tailed.
So it's just the number that's there.
Yes.
Yep.
Okay. So I got 0.995.
Yes.
Yes.
Okay. I'm not floating in outer space somewhere. Hooray.
Yeah, now number 12. We fail to reject.
Yep.
Yep.
Yay!
Hey guys, 3 more questions.
And I can do 13. You decide to try another alternative hypothesis. This time you use the mu value is less than 40 and you keep the same level of significance. Did the p-value increase or decrease? Well, it would decrease because we have to cut it in half.
It's true.
Yeah.
Yay!
I agree.
So then if we have to make that in half, if our p-value is 0.995 and we divide that by 2, it's 0.4975 and our alpha is still 0.01.
Yeah.
So we still fail to reject the null hypothesis, correct?
Yes.
Because it's larger than the
The alpha.
alpha. Thank you.
Oh, and so now we have to compare the... Oh, that's terrible. Well, okay, so now we have to compare the confidence interval.
Yeah.
But it should be the same because the only difference is that it's one-sided or two-sided. But you have to actually go and retake. Well, I don't know. What do you think?
It's the same.
Okay.
We didn't
do anything. We didn't change anything vital for it to change, so it's the same.
I agree.
And I've already submitted it, and we got 100%.
Like, I'm still solving the question, and you already know.
I can tell you with 100% confidence that that is the correct answer.
Like, I submitted it like 15 minutes ago. So,
That was great. Do we want to do the homework?
yes,
Sure.
I do.
Let's
Wait,
do it.
Kirsten, did you already do it while we were doing that?
No.
Are you
No.
scared?
I'm not going to be able to join you guys for homework because I have visiting teachers coming over, so...
Oh, whatever!
Hey, even though it's BYU, it's a thing. They actually do their visiting teaching here. We can't run away from them. They live in the same building.
Fine.
She's right. So, thank you guys so much. It's been fun working with you.
Thank you.
Okay, bye, Kristen.
See ya.
Sorry. See ya.
I like it.